Chapter 2, Section 2 is about solving one-step equations. So some of the steps that you're going to want to follow as we go through problems in this section are going to be as follows. Number 1 is going to be finding the variable that you are trying to solve for. So whether that's the x, the y, m, whatever letter they choose to use, you want to be able to find the variable and kind of know that that's what you want to get by itself. Step 2 is to clear any parentheses that you might have, and this is usually done with multiplication or using the distributive property in order to get rid of those first before you start doing anything else in the problem. Once you've gotten those things taken care of, your goal is to get the term that has that variable by itself. So whatever the x is or the y or whatever the letter might be that they have, your goal is to try to get that letter on its own by itself. A lot of times that's done first with like addition and subtraction. So to move one of those terms over by doing the opposite of what you see. So if you see something minus a number, you want to add that over, or if it was a plus sign instead, then you would subtract it. Then sometimes we might have to do a little bit of work with the term that has the variable yet, where there might be something in front of the variable, like a negative sign, or it might even have like an actual number, like a 2 in front of the x or something like that. And in order to get that by itself, you need to use multiplication or division. Now, there's a lot of properties that I'm going to go over in this section, and they're all going to say very similar things. So they're all going to say something in the line of, whatever you do to one side of the equation, you have to do to the other side of the equation. Now remember, sides of the equation is all based on where your equal sign is at. So the equal sign kind of divides the equation into two parts, the left side, the right side. So if you multiply or subtract or add something from the left side of the equation, then you also need to do the same thing on the right side of the equation. The subtraction property specifically is talking about how if you have something with a plus sign, that you can subtract it over to the other side in order to get that letter by itself. For example, if I have x plus 14 equals 6, I see this plus 14 here. So to move 14 over to the other side, I would subtract it. And again, that equal sign is kind of, if you need to draw a line, or some of you might know that as the river. The river's kind of telling you that equal sign is just going to stay there throughout this entire problem. And so whatever we do to one side of the river, we have to do to the other side of the river. So since I subtracted 14 over here, we cross those off. We bring down that x, bring down the equal sign, and then I still need to do this math. 6 minus 14, which would be negative 8. So there's two practice problems here that are very similar to that example. So pause the video, try these practice problems, and then resume watching to see the answers. So for this first one, x plus 23 equals 52, I would subtract 23. And then I would have x equals 29, because 52 minus 23 is going to be 29. Now the second practice problem is similar to those other two. They just wrote it backwards. They put the x plus 7 on the right-hand side instead of it being on the left side of the equal sign. I still see that plus 7, so I'm going to subtract 7, again, from both sides of that equal sign. Again, if you need to kind of draw that line down to let you know where the equal sign is going to be, that's fine. So then we have bring down the x, bring down the equal sign. 41 minus 7 is going to be 34. And some of you might have left it here. You might have said, there's your answer. And some of you might have switched it around using the symmetric property to say x equals 34. A lot of times when we're talking about algebra and like solving for something like that, we like the letter to be written first. So it's okay if you want to switch it around and say x equals 34 instead. Now, very similar to that subtraction property, we have the addition property. which again says that if you add something on one side of the equal sign, you need to add the same amount to the other side of the equal sign. So instead of it saying x plus a number, it's now going to say x minus something. So like this one says, x minus 5 equals 14. And in order to solve for x, I'm going to add 5 to both sides. And 14 plus 5 is going to be 19. So we're going to have x equals 19. So go ahead and give this practice problem a try. So what you should have done here is added 8 over. And that should have gotten you x equals 24. Now for this next example, there's a lot of negative signs going on here. So what I would have done first is gotten rid of, especially this double negative that I see happening right there. So what I'm going to do is follow like my keep, change rule. So right now I'm going to drop down 5/3 and the equal sign, because I'm not going to do anything with those. I'm going to bring down that negative x, because remember you always keep the first term. And then you change the next two signs. So notice how both of those became plus signs. Anytime you guys see a double negative like that in a row, it's going to become a plus sign. So this is now going to say negative x plus 1/4. Now in order to get x by itself, I need to move that 1/4. Since right now it says plus 1/4, I'm going to need to subtract it. Again, from both sides of my equation. Draw that river in there if you need to. So these 1/4 over on the right side are gone, and I have that negative x left, and I bring down my equal sign. Now 5/3 subtract 1/4 is going to be 17 over 12. And that's me keeping it as an improper fraction. Sometimes calculators might give that to you as a mixed number, which is fine as well. That would be 1 and 5 over 12 instead. Now, I'm not completely done because x has this negative in front of it, and I need to get rid of that. And in order to do that, I need to divide both sides by a -1, because we always want our letters to be positive, not negative. So all that's going to do to my problem here is switch where the negative sign is at. So the x becomes positive, and the fraction becomes negative. So take a minute here, pause the video, and do this practice problem, and resume watching when you're ready. So the first thing you should have done here is change the negative to a positive. So it should say -3 plus x now equals 71. And some of you at this point might have wanted to switch the x and the -3 around. So you might have written it like this. And that's fine. Either way that you go about this problem, you're going to get the same answer. Because on both of these, what you should have done next is added 3. Get you 74. All right, let's take a look at a couple of word problems here. So this first one says that a bridge is x feet long. It is going to be replaced with a bridge that is 30 1/3 feet longer. If the new bridge is 210 feet long, how long was the old bridge? So this old bridge, or the current bridge, is x feet long. And this new one is going to be 30 1/3 feet longer. So that means that it's going to be increasing its length. So we're going to add 30 1/3 to that x. And the new bridge's length is going to be 210. So that's how I would set up my equation here. Now I want to figure out how old the long bridge was, so I want to figure out what x is. So I'm going to subtract 30 1/3 from both sides. And that's going to give me 179 2/3 feet. So I want you guys to take a minute, read through this practice problem, pause the video here, give it a try, and then keep watching to see what the answer should have been. And I will warn you to read this one extra carefully, because I do see students get confused about how this one's worded a little bit. So the key thing here is that it says it is 15 degrees colder than what it was. We don't know what it was. That's what they're trying to figure out. So I'm going to call x for my original temperature. Now it's 15 degrees colder, which means that it went down 15 degrees, so I need to subtract 15 and set that equal to the current temperature now, which is 55 degrees. So then I'm going to add 15 over, and I'm going to be left with 70. So the morning temperature was 70. It's gotten colder throughout the day, and now it's 55. All right, if we turn the page here, the last two properties are division and multiplication, very similar to addition and subtraction, that whatever you do to one side, you have to do to the other side. So if you multiply on one side, you multiply on the other side. Same with division. So these first two, I'll do this first example, and you guys will do the practice problem here. To solve for something like this, 3x equals 5. 3 is being multiplied to the x right now. The opposite of multiplication would be to divide. So to get rid of that 3 in front of the x, we need to divide both sides by 3. And so we're going to get x equals 5/3. So you go ahead and try the practice problem. So you should have divided by 4 and gotten 5 for x. Now, problems that involve division are very similar. A lot of times what you'll see in these problems that they're written with a fraction, or they'll have some fraction part to the problem. So this one has x divided by 4. In order to get that 4 out of the denominator of that fraction, because right now it's x being divided by the 4, we want to multiply. So you're going to multiply both sides by that number in the denominator. So times by 4 on both sides. That'll get the 4's on the left to cancel, and that'll leave us with just an x. And then 6 times that 4 would be 24. Now, if you take a look at the practice problem, when they give you a whole fraction on the front of that variable, so a little bit different than that last one because it doesn't say just x over the 3, we've got this negative 2/3. You need to multiply by its reciprocal. And remember, we talked about reciprocals last chapter when we went over all those properties. Reciprocals are when you take a fraction and you flip it upside down. So we're going to multiply by a negative 3/2. That's flipping that fraction upside down. And over on the other side, you can think of that negative 6 as being negative 6/1. So x would be equal to, this is going to turn to a positive 18/2, which simplifies to just 9. So x equals 9. Now, the last couple of problems on the last page here are working with this equation for distance equals rate times time. So this would be an example of when you're driving somewhere and you know how far you need to go, you know what your speed is, and you want to figure out how long it's going to take you to get there. That's when you might want to use something like this equation, D equals RT. So for example, you are traveling 95 miles at a rate of 70 miles per hour. How long will it take you to reach your destination? So I don't know what my time is. I know how far I'm traveling, so that would be my distance, and I know how fast I'm traveling, that would be my rate, my R. So I need to figure out what my time is. So in my equation, D equals RT. In for my distance would be my 95 miles. In for rate, R would be 70, and T would be time. And so I'm going to divide both sides by 70. So I finally get my T alone here. And then 95 divided by 70 would be 1.36. So you're going to get a decimal, and that would be hours. Now, don't get that confused with like 1.5 hours, because that's not what that's saying. It's saying 1.36 hours. 0.36 of an hour is not the same thing as 30 minutes. If you wanted to figure out how many minutes that would be, you would need to take that decimal, 0.36, times 60, because that's how many minutes are in an hour, and that would tell you how many minutes in an hour it would be. But it would be 0.36 of an hour. So it would be less than 30 minutes even, because it's not even half of an hour there. So take a minute, pause the video here, and try to do this practice problem. So using that same equation, D equals RT, I'm going to put in 30 for the distance and 13 for the rate. T is missing, so I'm going to divide both sides by 13. My time here is 2.31 hours. Next example here says that Bob worked 4 times as many hours as Joe, and Bob worked 48 hours. How many hours did Joe work? So we need to use something to represent Joe's amount of time. So I'm going to just use the letter J for that. Now it says that Bob worked 4 times as much as Joe. So I'm going to write 4J, 4 times the amount of Joe. And that equals 48 for Bob's total. So then to solve this, I would divide both sides by 4. So Joe would have worked 12 hours. Okay, so take a minute and try to do that practice problem. So there's 12 people on a team, and I don't know how many teams, so I'm using T for teams there. I know there's 108 people total. To solve this, I would have divided both sides by 12. And I would have gotten 9. So there were 9 teams that were able to be created.